Welcome to PRISCI-ANTO Educational Academy. Today I am going to explain you the canonical form in linear programming problem in operations research. Let us see first what is canonical form. So after that, I'll explain you a simple problem. So the general linear programming problem can always be expressed as maximize z is equal to c1x1 plus c2x2 plus etc. plus cnxn, subject to the constraints a11x1 plus a12x2 plus etc. plus a1nxn less than or equal to b1, a21x1 plus a22x2 plus etc. plus a2nxn less than or equal to b2. Continuing in this way, am1x1 plus am2x2 plus etc. plus amnxn less than or equal to bm. Under the non-negativity restrictions, x1, x2, etc. xn is greater than or equal to 0. This form of LPP is called as canonical form. Okay, so let us see example. So example is express the following LPP in the canonical form. Maximize z is equal to 3x1 plus x2, subject to the constraints x1 plus 2x2 is greater than or equal to minus 5. 3x1 plus 5x2 less than or equal to 6. And the x1 comma x2 is greater than or equal to 0. The answer is the canonical form is in the constraints, subject to the constraints is given. First constraint is given x1 plus 2x2 minus 5 2x2 is greater than or equal to minus 5. So we have to make it to less than or equal to. So canonical form, every constraint less than or equal to must be less than or equal to. So canonical form is maximize z as it is. You have to write z is equal to 3x1 plus x2, subject to the constraints minus x1, because greater than or equal to minus 5 is given. So by minus I am multiplying. So minus x1 minus 2x2 less than or equal to minus of minus 5 will become plus 5. So if you want to change it to greater than or equal to 2 less than or equal to, you have to multiply with minus 3x1 plus 5x2 less than or equal to 6, and the x1 comma x2 greater than or equal to 0. This is the canonical form of a given LPP, right? Second problem is express the following LPP in the canonical form. Minimize z is equal to x1 plus 4x2, subject to the constraints 3x1 plus x2 less than or equal to 5, minus 2x1 plus 4x2 greater than or equal to minus 7, and x1 x2 greater than or equal to 0. So minimize z, it must be changed to maximize z. So minimize z, which is equal to minus maximum of minus z, which is equal to maximum of z star. So maximize z star is equal to, by minus you got to multiply. So minus x1 minus 4x2. x1 plus 4x2 is given, but we have to change it to maximize z. So maximize z star is equal to minus x1 minus 4x2, subject to the constraints 3x1 plus x2 less than or equal to 5. One constraint is given greater than or equal to 7. So that's why we have to make it to less than or equal to. So 2x1, by minus we have to multiply 2x1 minus 4x2 less than or equal to 7 and x1 comma x2 greater than or equal to 0. So third problem, express the LPP in the canonical form. Maximize z is equal to 2x1 plus 3x2 plus x3. Subject to the constraints 4x1 minus 3x2 plus x3 less than or equal to 6. x1 plus 5x2 minus 7x3 greater than or equal to minus 4. And x1, x3 is greater than or equal to 0. x2 is unrestricted. So this unrestricted means, okay, so it's a different. So we have to make it to restricted. x2 also make it to restricted. How to make it to restricted? I'll explain you. The answer is given x2 is unrestricted. That means you have to take x2 is equal to x2 dash minus x2 double dash. For x2, I have taken x2 dash minus x2 double dash, where x2 dash and x2 double dash greater than or equal to 0, not unrestricted now. So x2 is unrestricted means any x1 or x3 or x2, anything is unrestricted, you have to solve in this way. So the given LPP becomes maximize z is equal to 2x1 plus 3 into what is x2? Instead of x2, you have to substitute x2 dash minus x2 double dash. Okay, so plus x3 subject to the constraints 4x1 minus 3x2 dash minus x2 double dash plus x3 less than or equal to 6. Next one is, as it is, you have to write first, you have to substitute for x2 because it is unrestricted. So next x1 plus 5 into x2 dash minus x2 double dash for x2 minus 7 x3 is greater than or equal to minus 4. x1, x2 dash, x2 double dash and x3 greater than or equal to 0. Now you have to convert the second constraint less than or equal to type by multiplying both sides by minus 1. Okay, so because the canonical form, every constraint should be less than or equal to. That's why maximize z is equal to 2x1 plus 3x2 dash minus 3x2 double dash plus x3. Subject to the constraints 4x1 minus 3x2 dash plus 3x2 double dash plus x3 less than or equal to 6 minus x1 minus 5x2 dash plus 5x2 double dash plus 7x3 less than or equal to 4 and x1, x2 dash, x2 double dash, x3 is greater than or equal to 0. So which is the canonical form. Thank you.